does anyone know what decoupling is, or if you've ever heard maybe as a criticism, like this is too tightly coupled or anything like that, for those of you who've. So if you haven't heard that yet, that is definitely something that you will hear at some point. So components being tightly coupled. So I mean, there are a few kind of like basic maxims that you're going to want to keep in mind as you're programming. Things like don't repeat yourself, and when you're writing a function, you don't want your function to be 50 lines and do 10 different things, right? So you want functions to do kind of one very specific thing, and that thing should probably be reflected in the name of the function, right? So having things that you're not repeating yourself, having things be very focused and modular and decomposable. So this is part of that ideal. So keeping things decoupled at a very kind of low level means not trying to do too many things at the same time, and also maintaining some flexibility. And we'll see an example of what that looks like. So one way of maybe this is not like strictly speaking tightly coupling, but maybe kind of at the lowest level, something like this, where in Python, we have a print function, right? And the print function is very general, like most things in Python, because Python uses duck typing, right? So the ideal of Python is that you shouldn't really care what something is, you should just care what it can do. So if something is convertible to a string, then you can call print on it and it'll print out that thing, right? So Python, unlike other languages, it's not going to check the type. It doesn't care about the type. It's just, can you do this thing? Does your thing follow the API? Does it follow the protocol? Right, so we get more flexibility there with the Python print function. And something like this. So we have this function. I'm just going to copy and paste this here. So we have a function here, right? Make API call, write to file. And maybe it's not the best function one because it does two things instead of one thing. But aside from that, and we could also maybe import these outside of the function. That's not so important. But let's imagine the HTTP request is either a class or a library. It's something external that we're importing, right? And we're going to use it to make an HTTP request. And file writer is either some kind of class or component, maybe in our code or in third-party code, and we're importing it, and then we're going to use it. So this function, right? So I'm going to make an HTTP request using this, say, class. So this class has a get method. So I'm going to make a request, and I'll get some kind of result back. Then I'll maybe convert this result to a string. Maybe I get it in JSON or something like that, or convert it to an object, whatever, some kind of processing. And then I want to write this information to a file. So I have this file writer class, which has a write method, and then I close the file afterwards. So can you imagine any problems with this? Well, one issue that you might think of is maybe
memory.
Yeah.
The memory, because like if the data is really long, if it's a really long HTTP response, then you have to have enough memory to store the whole file in one data object.
Okay, so that's a good point, sure. So Yeah, so if we get JSON, depending on how we're parsing it, we might want to chunk. We want to do some chunking to make sure that we're not overwhelming the memory. So that's a good point. That's not it. So I'm trying to get at something else, but that is definitely something good to think in mind. Good to have in mind. So one thing I'm thinking of is maybe we have a special case where we have to use a different class, a different kind. We need to make a different kind of HTTP request, or we need to do something special with the file writing object. So if we need to use, let's say, a different HTTP request class, then what we're gonna have to do is probably just write another function here, right? And HTTP2 request, right? We can keep the rest of the stuff the same. So now we've got two functions, right? And if we need to use this one, then we'll call whatever. We'll call this one too. So if for a special case, we'll write this function and we'll call this one. But of course, now we're repeating ourselves. So what we're probably going to want to do is somehow make this dynamic. So right now we're basically hard coding the specific HTTP requests component and the file writer component. So we probably want to make these dynamic if possible. So we can make them dynamic by injecting them as dependencies. So here we have dependencies, right? We have two dependencies. These are two classes, let's say, two classes that this function depends on. So instead of hard coding them, let's inject them. So instead of doing that, right, so now we just made this function more flexible and generic. So now when we call it, we pass it whatever instance of the HTTP class and whatever instance of the file class. We could even do, default parameters or something like that, right? But in general, that's the basic idea of dependency injection. So we're making this flexible now, as long as the class that we use to do HTTP stuff has this API, as long as it has a get method, right, that takes maybe a URL string, and as long as the file object has a write method, right? So as long as it's following these rules, and you can also, of course, implement these or wrap these to make sure it's following the rules, but as long as that's the case, we're basically doing duck typing here. So this function no longer cares specifically what class we're using, what HTTP request class we're using. All it cares is I'm getting something, and this something has a get method. So now that's all that this cares. It doesn't care what this is anymore. It just cares what it can do. So here's, that's the basic idea. So just like to show a quick example. So feel free to look at the README and play around with it if you would like. But we have an example of modeling DMV, right? So you have a DMV driver's license application. Then there's a like the actual DMV office, and then there's a DMV employee. So someone fills out the application, they submit it to the DMV office. The DMV office finds an appropriate employee, and then the employee fills out the application. right? So if we look here, so the specifics aren't really important. This is just a silly example. But notice here we have a class driver's license application, and there are no external dependencies in this class, at least no hard-coded external dependencies, right? So we could have a class here and then instantiate the class right here, and that would be fine. Not necessarily anything wrong with that, but here it's not going to be obvious just looking at it. But here we're actually passing in an instance of another class, right? So this method accepts an instance of another class, and which in this case is the local DMV class. And then this method, submit application, doesn't care what this is, right? It doesn't care what local DMV actually is. It just knows, like, I get a thing and I call move line. I call the move line method on it. So we can control what the local DMV actually is, and frankly, we can pass it any kind of class or object that has a move line method on it. It doesn't matter. It doesn't matter what it is, as long as it has a move line method, right? So this local DMV also has some dynamic dependencies. So again, there's nothing hard-coded. There are no hard-coded dependencies in this class. But this move line takes an instance of the application, right? Which is right here. So I call move line, I pass it an instance of the application. And then local DMV, again, it gets an instance of the application, and it can do, again, it doesn't care what the application actually is or where it comes from. It just cares about what it can do. Like, does it have a license type property? If so, then it can use it, right? Doesn't have to wonder, what it actually is. So employee process license, right. So we'll talk about it in a sec. So so this method also takes an employee, which is an instance of the employee class, and it accepts an instance, and then it adds it to its list of employees. So the DMV employee class also accepts the application. So the application starts here, it goes to the DMV, and then from the DMV gets passed to the DMV employee. And from here, this DMV employee class, the instance of the application is modified, and then it's printed. So all of this is happening. So all this stuff could be hard coded, right? So we could go employee. We could do something like employee equals, import employee from whatever. Employee equals, instance of employee, and then maybe do a for loop and just create a bunch of them or something like that. So you definitely could do that. But if you did that, then you're kind of limiting yourself to only doing that specific thing. Whereas here, this employee object, if your application changes later, you have different kinds of employees maybe, this won't be affected. So here's a runner. You can take a look at that. So I also just want to briefly mention testing. There are some implications for testing. So when you when you're using dependency injection and you want to do unit testing. So when you do unit testing, the ideal, of course, is that all unit tests are isolated, right? So unit tests should have no dependencies on anything else in your application. So if I want to test the local DMV class, I shouldn't, even though my local DMV class maybe is making API calls and interacting with other classes and doing all kinds of other stuff, for the purposes of the unit test, that shouldn't be happening. So we don't want any external dependencies in a unit test. So what we do is we fake them basically. So if we have any external dependencies and we're doing unit tests, especially for things like getting stuff from a database or an API call, so things that are totally basically outside of the control of your application, you definitely don't want to make those dependencies on your unit test, because if the server goes down, your unit test will fail and it won't really tell you anything about your application exactly. Okay, so unit test comes with mock. So any testing framework is going to have this capability. Unit test has this mock. So patch and mock are basically the same thing. There's a mock class which has all this functionality. So what we're doing here is we're saying find DMV employee.dm, so file class. So find this class and then basically replace it with this patch object, which is like it's a mock thing that Python unit test takes care of. And we're going to call it fake employee. So we're basically going to replace this class with this fake class. And then we can add properties to it. We can change it around, and then we can use it. Right? So this function takes an instance of the employee class. So we'll pass the fake, employee instance there. And then we can just check if the number of employees has increased. Right? So that's patch. So same thing here, same thing again. We're creating a fake employee. We're basically overriding this and replacing it with this fake object. And then here, we're doing the same thing, except it's not just an object. We're actually gonna replace a method, right? So here we're gonna do self.local.dmv.moveLine fake app. And then there's a method in this driver's license application called process license. So we look at the driver's license application, there's something called, what was that? No, it's in the DMV employee process license. So we're faking the employee, and we can actually check to see if this fake object, if our code tried to call the process license. So it's these mocks are nice because they allow you to do other things like test how many times a function was called, for example. You can do things like that. You can test what parameters was it called with, what did it return, and so on. So I wouldn't overuse this, but it's a little bit, it's a more complicated feature of unit testing. So that's all. I just wanted to.
I don't think I quite understand that. Like with the patch, you're just replacing one thing with another thing.
Yes.
So like, what's the benefit? Because you still have that dependency in the file, like dev employee is still a dependency in the file.
Yeah. So what I'm doing is I'm only testing the local DMV class. Right. So all this stuff is real, but any dependencies that this class has, like employee or application, I fake those. I fake those because I don't want, if something's wrong with the rest of my application, like this driver's license application class, if something's wrong with that, then that's going to affect this unit test, right? So I don't want that to happen. So any any dependencies, any external dependencies that are outside of this class that I'm testing specifically right now. Anything like that, I will probably want to fake.
Just to add on to that, if it's still not clear why you might want to fake a class entirely, is it's jumping ahead a little bit, but you might have a class. Chad said it earlier. You might be making an API call, like that class when you build it or access things or call a method. It might reach out to the internet and grab stuff, and you might want to prevent that in your unit test. You might not want your unit test to actually go to the internet and grab stuff. So you would fake the object. You would say, I want you to look and act like a DMV employee, but I don't want you to actually go out to the internet ever. I don't ever want this unit test to try to go out to the internet, but I want you to fake the data just so we can test the DMV. I want you to fake what the response might be from an API request. You'll get to APIs later and API requests later, but I want to fake this data set that would have come back from the internet, because it doesn't matter for this test. It only matters to test the DMV, not the employee. So you're like faking the employee's abilities. So you're giving it attributes, right? Like you're like, where did it go? Oh, so in the unit test, he's basically doing a patch. It's mocking a DMV employee. And then he's doing direct assignment, right? He's saying fake employee dot name equals Joe. He's giving fake employee an attribute, an instance attribute called Joe, without doing like the creation of the constructor and passing it and any of that stuff. So basically, you're potentially preventing calls out to the internet that might actually happen. It really depends on the code base and what you're doing. I've seen it done in open source projects though, where they fake they fake objects all the way through, because some of them are actually like hitting YouTube or something, like they're trying to scrape data off of something. When you actually use the class, it actually like tries to go use regex and parse something from the internet. And you're like, I don't want to run 100 tests and have it hitting YouTube for every single test. I just really want to test this one little thing, like the DMV class. Everything else can be faked along the way. I just want to make sure DMV would work. But yeah, that's probably the best case scenario I can think of, is when you're like reaching out for real data off of a server or something, like an API request.
Yeah, I could see that like off of a Google, like Google Maps, where they where they charge you per hit. Or
yeah, anything AWS or anything that might physically charge you for usage, or you just don't want to like spam a bunch of test cases at somebody's website, because it might look like you're trying to just spam, like hit them with a lot of loops run fast, right? So if you hit get request a bunch of times on a site, it looks like you're trying to like take their site down with extremely fast code. But there's a lot of reasons not to do it. But in the patch is not easy to grasp when you first are introduced to it, but it is faking an object just for the sole purposes of, so you can test a different feature while not worrying about your fake employee. It's really just imitating that class. But yeah, you'll see its usage later. I didn't understand the usage of it when I first seen it, but it is pretty useful for those cases. Just knowing it exists is half the battle. And I'll shut up now. Sorry, Chad.
Thank you. Thank you. That was good.
So just to clarify, so like, would you also be able to use it, like, say if you're like writing the code and you have the idea that you know you're going to need to write this object, and you know that object is going to need these methods, can you just like essentially say pass for all of it, and then fake that object so it's an incomplete object, but you can still test what it would be used in, like the dependencies that it would be used in?
Yeah, are you talking about like actually creating like a fake object to use in testing?
Yeah, so for example, like if you were working on this code and you were starting from scratch, where you like wrote class test local DMV, or like the local DMV, and then class employee, and like you had nothing to start with, and you just said, I know the DMV is going to need to have a process line like method, so you could just write process line and then pass. And then when you go back and you're like working on the application piece and you need to test it and it's dependent on the DMV,
Right.
even though you haven't written the DMV object yet and it's incomplete, you can still test because you
Yeah,
have like
exactly.
a mock version.
Yeah.
It's like it's literally not written yet, but you can still test with it.
Yes. So if you know that the class that you're working on is going to have a dependency, and you know what that dependency, what that dependency is going to look like, what methods are, then yes, yeah, absolutely, you can fake it. So if you knew exactly what you were doing, you could basically fake the entire application and then write it one component at a time. Yeah. So I wouldn't necessarily overuse this, but there definitely are use cases, especially when you're doing like side effect things that require external. So again, like as Chris was talking about, so one, there's financial issues. I don't want to make a whole bunch of API calls just while I'm testing, because I might have to pay for those. Two, if something breaks, are you sure that it's like the logic in your code that's wrong, or is maybe the server is down? So you're never quite sure, because you're kind of testing two things at the same time, right? You're testing your third-party API, and you're also testing your code.
Can I ask to go back a little bit?
Sure.
When you are, for example, doing the patch DMV employee as fake employee, is that making fake employee an instance of the class, or
No, so
where does it come
we'll
out?
talk about this with statements. We've seen it a bunch. It's one of those things we've seen it a few times. I haven't really talked about it. So we're going to talk about files on Thursday. So we'll see this. But this patch takes a string, and this string is basically just like an import. So from DMV employee whatever file dot DMV. So this is the file name, and this is the class name. So basically what we're saying is override this with the built-in Python unit test mock object. So anytime I call DMV employee, Python is like going to interrupt that call basically and replace this with the fake object. So it's kind of like if you did, what Python is doing is a more sophisticated version of this. So this works, right? It works because I've just like overridden, I've kind of like overridden this name. So there's something similar is happening here with this patch. It's saying, hey, this name, you're kind of out of the game now. We're gonna use this now.
So does that does it take in all of the methods and dependencies that were in DMV employee and assign them to fake employee, or do you have to do that in a
No,
separate
it's its own very kind of weird object that doesn't have anything in it. It's just this mock.
and then you assign the name, assign the specialty?
Yeah, so it's actually an interesting thing. I should probably like look into it more, but it will basically just, if you call it, so if I do employee.name, it will create that. So I can add whatever feature I want. I'm not restricted to things that are. So, but
you wanted to add like employee dot favorite color, even though that's not part of the DMV employee class that we're pulling from with the patch line.
Yeah,
you could add whatever you want,
right,
for your test. So as long as you know what DMV employee needs for the test to run, you'll just put it in there kind of manually.
Yeah.
To run the test. Gotcha. Okay, thanks.
And notice that like this, I don't even think that this is necessary. So you really only need to put specifically what the test needs to pass. So, right, so that's just something else to keep in mind. So again, all of this is more, just think of this in the way of kind of exposure. So dependency injection, this is a specific thing, but the general idea is it's the same principle, right? Keep your code kind of flexible and able to be modified in the future. So avoiding like hard coding and things like that. And then, this is just a this is just a more advanced feature that you can use with unit tests. All right, are there any more questions? All right, let me go over the challenge. So if you didn't finish the challenge from yesterday, I would go ahead and do that. And if you have finished it, then here's a fairly open-ended one. So ice cream and freezers. So kind of, I would spend a little bit of time just trying to plan this out. How do you want to organize it? How many classes do you want to have? I think at least 2, but maybe 3. And also just ignore all of this stuff. There's a whole bunch of very technical stuff. Just ignore everything and release. So, but yeah, just think about how many different classes you want to have, how you want things to be connected, maybe even draw it out before you start coding. And this is very open-ended, so yeah, that's all I got.